cantilever of a square section 200 mm into 200 mm and 2 meter long just fail in flexure when a load of 12 kilonewton is placed at its free end. That means I was having a cantilever beam, and this cantilever beam was is of square in cross section, and it was of 2 meter length, and it fails when a load of 12 kilonewton is placed at its free end. Okay. Second part is a beam of same material and having a rectangular cross section of 150 mm wide and 300 mm deep is simply supported over a span of 3 meter. Okay. Now, same material beam, but this time its rectangular cross section was 150 mm and 300 mm. 300 mm is vertical and 150 mm is this length, right? Is simply supported, and it was simply supported over a span of 3 meter, and now it is a span of 3 meter. Now he is asking, calculate the minimum central concentrated load required to break the beam. That means on this beam, whatever central concentrated load, how much we should apply on it so that it will fail. How much central concentrated load to be applied on the beam so that this beam will fail. Okay, just like the beam has already failed in the first case. Okay, let us see the solution of this. So like this, we have to draw the representation of this. It is very, very important. You can write down in the same manner in your answer sheets or in the examination also. Now this is the cantilever, 2 meter length, 12 kilonewton is applied, and in this position it will fail. Okay, and this is the side view enlarged 200 mm by 200 mm. Okay, then he is saying that same material beam, and you have to find out W. W is minimum central concentrated load required to break the beam, and beam is of this type, that is it is simply supported of 3 meter length, and W is this, right? Okay, and this is the cross section of the beam, that is 150 mm by 300 mm. Okay, so ultimately in this numerical, what you have to do is you have to find out the value of this W, that is the minimum central concentrated load required to break the beam. That's what you have to do. Okay, so let us try to find out the way how to solve this numerical. So for this particular case, the formula is m over I is equal to sigma over y, right? Okay. For this case, as this particular case is in matching with the 5 case which I described you earlier, right? So for this particular case, value of m is W into L by 4. Okay. Then value of I is, it has to be like this only. Value of I is 300 whole cube into 150 upon 12. Then sigma, I do not know what is sigma because he has not given any value of sigma. Okay, but he has given the value of y. Okay, now in this, if I put all these 4 values into this, if I put all these 4 values into this expression, then also problem is I do not know sigma, so I cannot calculate the value of W, which he is asking, right? So that means now you should know the value of sigma before calculation of W. Okay, now how to get sigma, that is the question. For that value only, he has given you the first this exercise or first this step, and in this step he already said that this cantilever fails in this position. That means because of the applied bending moment, it crosses its permissible limit of sigma. That means whatever the sigma is experienced in this case, for that value of sigma, the beam will fracture or the beam will fail. I'll again repeat it, because in this case, for this value of bending moment, it will experience that value of sigma for which this particular beam will fail, right? And in this case also, he is asking that value of W for which this particular beam will fail. So for that value of stress we'll get from this equation, because material is also same, so that sigma or that value of stress will use in this second case, right? So in the first case it is very easy. M over I is equal to sigma over y, and M is equal to W into L. For this, M is equal to W into L. I is equal to 200 into to the power 4 upon 12, because it is of a square in cross section. Sigma you have to find out, y is equal to this. Now still it seems to be that question is very easy and you can always put all these 4 values and you can get the answer. But still there is one very common mistake that students do in this. And what is that? That mistake is actually the mistakes of units. We never write down units in this case, that the value of this M is 24 kilonewton meter. In this we never write down the value is 200 to the power 4 upon 12 millimeter to the power 4. What should be the value of this sigma? We never write. What should be the value of y? We never write. Or sometimes we write for this, but we never write for this M or probably I. So for that I try to solve this numerical and I just transferred the values into it. So if we carefully write down all the values, then we came to know that in this case this meter we have to change into millimeter, right? That is why in this case I had written here 1000 kilonewton millimeter, right? And because of that only I'll get the value of sigma, and this sigma value is 18 into 10 raised to power minus 3 kilonewton per mm square. Now it's very easy. I can put this value of sigma into the second case. Second case means into this case, right? And once I know the value of sigma, then I can always get the value of W which he is asking. So in this, M over I is equal to sigma over y, or M value of M I can put across, and in the same manner I'll put all these different values to it and we'll get the value of W, and W is 54 kilonewton, right? Okay, thank you.